Welcome, my name is Jarosław Dudek, and since this is Friday 5 p.m., I will try to make my talk pleasant and easy to understand. The topic is synchronization primitives in the standard C++ library. In fact, I will show you alternatives to condition variable. So let's suppose you have the hardware, multi-core CPU, you got a lot of threads, and you want to synchronize those threads. So this is the basic example. When we and I will show you how we can synchronize threads based on this example. So the idea is that we have the worker thread, we have the main thread, and we want the worker thread to signal the main thread, and we will need to use some kind of synchronization primitive. On the right, you see that we would like to print on the screen the quick brown fox jumps over the lazy dog. So if you think about this, how we can notify another thread from the one thread, then probably the first thing would be condition variable. At least a lot of this was the only option for. So this is the solution with the condition variable. This is the code written in the C++20. And as you can see, we basically doubled the code size. So we just introduced the synchronization primitive and just send a notification. But in fact, we added 8 lines of code. Okay, so the amount of code might be not the problem. But the bigger issue is that with the condition variable, we have the complexity. It's just the condition variable. We always need to use mutex and some shared variable. So on the lines 3, 4, 5, this is not optional, this is mandatory. When you check the API for the condition variable, you won't notice the shared state, so this bool ready flag that is needed. You basically need to read the documentation and understand that this is needed. And one of the common faults with the condition variable is on the line 16 when we are waiting and we are not checking the shared state. Here you see the correct code. So we are using the CP, we are passing the lambda predicate, and we are that the condition was fulfilled. Another problem variable is the performance. We are using the mutex, and mutex is heavy synchronization primitive. So for example, on line 10, you see that we are notifying the thread while still we are holding the mutex. And the question, can we unlock the mutex after the line 10? And the answer is yes and no. In this example, we can unlock the mutex and notify. It won't give us a problem. But if we are tight on the schedule and there is a possibility that this main thread would destroy the condition before the worker thread is executing the node, then in this case, we need to lock the mutex when we are notifying. So the problem is we have a lot of code. We need to write the code exactly as it should be. And as you know, for every 3 lines of code, there is one bug. And you don't want to investigate bugs on the Friday, 5 p.m. So can we do something better? With the C++11, we can use future and promise approach. So here you see that the code is simplified a lot. There are some restrictions. The first one, with the future and promise, we need to allocate something on heap. So sometimes it's not possible. But more important restriction is that for the promise, we can set the value only once. With the condition variable, we can periodically send notification. Here with the future and promise, we have just single event, one-shot usage. And also there's one thing that might be hidden and it's not visible here. Because we have the promise and the future, those might have been owned by different threads. And here we have the shared state that is connecting the promise and the future. So we need to take care about the lifetime of both primitives, the future and the promise. And when this is a problem, if the cancellation comes into picture. So when the set some value of the promise cannot set this value because there was a time or something like this. Usually we can use exceptions, but we cannot destroy the promise because then the thread that is waiting for the future would not work as expected. And basically for the C++ 11, 14, 17, this was more or less the only alternative that was simpler and reliable. I'm not talking about different approaches with the spin locks and other primitives, just something that is simple and easy to use. But with the C++ 20, we got a bunch of new options. We got atomics that were enhanced with the waiting and notification. And we also got some higher level primitives, latch, barrier, and semaphore. So I will show you those 4 approaches applied to our simple example. First, for the atomic bool, the synchronization primitive is simple. We have just atomic. We don't have mutex or the shared variable. The sending code, line 7 and 8, is a little longer than with the future promise, but still these are just 2 lines. We just need to change the value of the atomic and not the atomic variable. And the waiting part on line 12 is pretty simple. You can imagine that this is the predicate check from the condition variable baked into the wait method. So here on line 12, we are waiting until the atomic boolean will change the value from false to something other. And here, this approach is reusable, so it doesn't suffer the problem for the future and promise. But at this point, we need to take care about the ABA problem. So it is not guaranteed that if one thread changes the value to true and some other thread is changing the value to false, we will get the thread awaken on the line 12. So there are options how to solve this, but this is one of the problems that we need to take care of. In this example, there is no such situation, so this code will work perfectly fine. And when we were talking about the atomics, there is one special primitive. This is atomic flag. Basically, this one is something like the atomic bool, but here instead of storing value and checking value, storing true and false, we have just set and clear. So the difference is only on line 7. We have test and set to set the value to true. And here, why I'm showing atomic flag, this is basically just because of reason 1, that it's guaranteed to be lock-free. Other atomics can or cannot, but this one should be lock-free. So it means that this atomic flag approach should be the fastest. So after atomics, we have also new primitives. The first one I'm showing is the latch. The latch is just a counter. You can think that this is the counter. When we construct the latch, we are in the constructor giving a number. Here we are setting the number to 1. And each thread that grabs, that has access to large, can either decrease this counter. Here on line 7, we see countdown. Here we will decrease the counter by 1. The thread can also wait. And on the line 11, you see that we are waiting. Of course, there are other possibilities like arrive that we are declaring and waiting. But to have the similar code as for the condition variable, here I'm the countdown and wait. So this code is also just 3 lines to synchronize the threads. And it's also simple. If we want to have something more and we have the algorithm that is executed in phases and we need some reusable, then we can use barrier. As two differences than ledge. One is that it's reusable, and the second is that we can specify something called completion function. You can see on line 4 that we have this completion function. And what does the do? When the barrier counter reaches 0, one of the thread executes the completion function. So this will be executed just by single thread, not by all the threads that are executed. And after the completion function has finished, all the waiting threads will be unblocked. And for the barrier, there are also synchronous and asynchronous API. On the line 9, you see arrive and drop. This will just decrease the counter and block the worker thread. And on line 13, there is arrive and wait, and this will be waiting for the barrier to reach 0. So this is the reusable primitive. And also one thing to notice is that it takes care about thread ID. So on line 9, when we execute arrive and drop, we shouldn't call this arrive and drop 2 times from the same thread because barrier is taking care about the thread pool that is using this. And the last of the primitives in the C++20, this is the semaphore. For the semaphore, we have basically 2 options. One is the counting semaphore, and the other is binary semaphore. So this one is also initiated with the counter. The binary semaphore has this difference that we have the maximum value 1. Counting semaphore, we can have something higher. And you can think about the semaphore as some kind of mutex that is extended for more than just one thread. So until the counter in the semaphore is greater than 0, we can decrease the counter. So we can acquire the resources as it is on line 11. And when we execute the release, the semaphore will go up. So in this case, the binary semaphore is straightforward to just print our sentence. And this construct is perfect for the resource control. So when we have something like the pool of the database connection or the network connections, and we want to limit the number of thread that is using these resources, but we want to have more than just the one thread. So 15 minutes is up, so I will just go to the conclusions. The first one is there are a lot of possibilities, so we should choose the right tool for the job. All the options I've showed you in this presentation are valid. I'm not saying that you should stop use condition variable. It's up to you. Condition variable also has, so it's applications, and sometimes they cannot be replaced. For my advice is like, if we don't have the C++20 or we cannot use some other libraries, then future and promise is a nice alternative because this is the simple code. When we have more than 2 threads, so 3, then if we want to synchronize those, then barrier, latch, and are the best options to check if those will be okay. And there is a difference between the barrier and latch. So sometimes I've seen the code with usage of the barrier, but in fact the latch would be enough. So we don't want to reuse the synchronization primitive and we don't need the completion function. Maybe latch is sufficient for us. With the barrier, there might be a problem that one thread was getting out of the phases, so it's getting arrival token and we can have something unexpected. With the latch, we won't have this problem. Of course, for the resource control, we should use Semaphore. And there is also one synchronization primitive I was not showing you. This is stop token. This is connected with the JThread. I was not showing this stop token because we would just wait for the thread termination. But if you want to notify the thread stop its execution and you have the C++20, then you can check the stop token. So I hope that this was an easy talk and you will have learned something. And intention is that if you next time see the problem with the synchronization between, you won't try to use the sleep and just to postpone one of the threads. So that's all from my side. Thank you. And if you are interested in some nice job offers, there's the QR code you can scan. So thank you once again. And if there are any questions, because I was not checking the chat, I will answer this after the presentation.